I am B. Sujata, Assistant Professor, Department of Science and Humanities, Hindustan College of Engineering and Technology, Coimbatore. In this video, we are going to discuss about Newton's forward interpolation formula, which is used to find the in-between values when the values of x are equally spaced and x value occurs at the beginning of the table. How to form a Newton's forward difference table, and a problem is solved using Newton's forward interpolation formula. So Newton's forward interpolation formula is valid for estimating the value of the dependent variable at the beginning of the table, and the values of x should be equally spaced. So the forward difference operator is denoted by del. The first forward differences is denoted by delta y0, which is y1 minus y0. The second forward differences is denoted by del square y0, which is equal to delta y0 minus del y0, and so on. So the forward difference formula, how it is formed, is given in this table. The values of x are denoted as x0, x1, x2, etc. Then corresponding to x, the values of y are y0, y1, y2, etc. The forward difference is denoted by delta y. The second is denoted by del square. The third difference is denoted by del cube, and so on. So the first forward difference is formed by subtracting this y1 minus y0, y2 and y1, y3 and y2, and so on. The del square is formed by subtracting this del y1 and delta y0, del y2 minus del y1, and so on. So till we get a constant value, we are proceeding this table. So the Newton's forward difference formula is denoted as y of x is equal to y0, which is your initial value, plus p into delta y0. Delta y0 is your first difference. P into p minus 1 by 2 factorial into del square y0. Del square is nothing but your second difference, and so on. That this p is nothing but x minus x0 divided by h. Where this x is your unknown value for which we are going to find the value of y. x0 is the starting value of the table, and h is the difference between the values of x. So this h is common, since forward difference formula is applied for equal intervals. Let us see a problem how to use Newton's forward interpolation formula to find the value of x when it occurs at the beginning of the table. So the problem is, using Newton's forward interpolation formula, find f of 1.02 from the following data. Yes, so here what are the values of x? It is 1, 1.1, 1.2, 1.3 and 1.4. Corresponding to x, the value of y or f of x is given. Yes, so what's the value of x? That is unknown data. It is 1.02. So 1.02 occurs at the beginning of the table. So if it occurs, value of x occurs at the beginning of the table, we have to apply Newton forward interpolation formula. So before that, we have to check whether the values of x are equally spaced or not. So what's the difference between 1.0 and 1.1? It is 0.1. The difference between 1.1 and 1.2 is again 0.1. Then difference between 1.2 and 1.3 is 0.1. Then difference between 1.3 and 1.4 is 0.1. So throughout, the values of x are equally spaced. That is, h takes the value 0.1. Here x0 is 1, x1 is 1.1, x2 is 1.2, x3 1.3 and x4 is 1.4. So before applying the formula, we have to form the forward difference table. So the values of x and y, which is given in the problem. So y is nothing but f of x. So these two values will be given in our problem. So we have to form del y, del square y and del cube y, which are the forward difference values. So first, to find the first difference, subtract this 8.91 and 8.41, which is 0.050. Then 0.932 and 0.891, which is 0.041, and so on. To form the second difference, subtract these two values, then 0.032 minus 0.41 and so on. So the forward difference table is formed. Now we can apply the formula. So what's the formula? Y is equal to f of x is equal to y naught plus p into delta y naught plus p into p minus 1 by 2 factorial into del square y naught plus etc. So what is your y naught value? Y naught is nothing but 0.841 plus p into p is x minus x naught divided by h. P is x minus x naught divided by h. X is our unknown data, which is 1.02. X naught is the starting value, which is 1, and h is the different values of x, which is 0.1. So P is nothing but 0.2. So this 0.050 is your delta y naught value. Then del y square, delta naught y square is 0.009 and plus etc. So when you calculate, you will be getting the value as 0.852. So when the value of x is 1.02, the value of y or f of x is 0.852, which lies in between these two values. Yes. So when the values of x are equally spaced, we can apply Newton's forward interpolation formula. So and again one more condition is the value of x, that is the unknown value, should occur at the beginning of the table. If it occurs at the unknown value, if it occurs at the end of the table, we use Newton's backward interpolation formula, which we will discuss in the next video. Thank you.